Hi children and viewers. Today I am going to start new lesson, that is current electricity. This is the one of the chapter in the second year physics. In this video you are going to learn about few definitions. This is nothing but introduction of the chapter. First thing is you have to learn about this one, definition of current and definition of ampere, and what is the direction of moving of charges, and in which material charges can move, and what is Ohm's law, and what is meant by resistance, and what is definition of ohm, and what is meant by conductance. You have to learn all these things from this video. So children, all are very important definitions, so you must watch the video without skipping. While you are watching the video, my request is just simply like the video, and after watching the video you must post your opinion as comment. And if you can like my videos, subscribe my channel also. Children, I am going to talk now here current electricity. What is mean by current electricity? So current electricity is nothing but the branch of electronics that can explain about the properties of moving charges. So in this chapter you are going to learn about the properties of moving charges. So here, first thing, what is mean by current? Here, according to the historically the people can felt that the current is because of positive charges. The moving of positive charges can be considered as electric current. But now according to the modern electronics, the current is because of moving of electrons. Okay children, first we have to know about the definition of electric current. So we know about the conductor. What is mean by conductor? The device which can allows the current through them, that should be called a conductor. Clear? The device which can allows the charges or electrons to them, or that should be called a conductor. So in a conductor, so many electrons are there. Those electrons are moving from one place to the another place, and you have to assume that the electrons which are very freely, they only responsible for the electric current. Clear? So first thing is, what is current? Let us discuss here. I is equals to Q by T. So here I is equals to Q by T. For example, this is the one conductor. In that conductor, the charge can move. Within the particular time. That should be called electric current. The net amount of charge passes through a conductor in particular time. That should be called electric current. Got my point? The net amount of charge passes through a conductor in particular time. That should be called electric current. The net amount of charge that should be passes through a conductor in particular time is called electric conductor. If you can take instantaneous of time, simply you can take small interval of time, then we will write the same expression should be I is equals to dq by dt. This is the instantaneous current. The amount of charge passes through the conductor in particular total time of interval. In particular time of interval is called electric current. So children, this is the definition of electric current. I is equals to Q by T. The net amount of charge passes through a conductor in particular time is called electric current. So children, all of you know what is the unit of charge? Coulomb. And what is the unit of time? Second. Now here I am writing coulomb for second. coulomb for second, and this coulomb for second is nothing but that is the ampere. So here ampere is the unit for current. What's that? Ampere. Ampere is the unit for electric current. The electric current can be measured in terms of amperes. So clear? And now children, definition of 1 ampere. Definition of 1 ampere. Clear? Children, this is the important definition for 2 marks question. Define ampere. What is mean by ampere? Simply here we are writing 1 ampere is equals to 1 coulomb for 1 second. 1 ampere is equals to 1 coulomb for 1 second. That means how we can define that? 1 coulomb of charge passes through a conductor in how much time? 1 second. So 1 coulomb of charge passes through the conductor in 1 second, then the amount of current flow in that particular conductor is said to be 1 ampere. Clear? 1 coulomb for 1 second is nothing but 1 ampere. This is the definition of 1 ampere. If 1 coulomb of charge passes through a conductor in 1 second is called 1 ampere. Children, now here how we can identify? How we can identify the direction of current flow in circuits? How we can identify the direction of current in circuits? So generally children, for us 2 sources are there. 2 sources are there. There are 2 sources to explain about the or gives the electric current. The first thing is here. Generally in circuits we will mention that is the battery, and another source is nothing but dynamo. These 2 are main source of electric current, battery and dynamo. In battery, what we have to observe? In battery, chemical energy is converted into the electrical energy. In dynamo, what you have to observe? In dynamo, mechanical energy is converted into the electrical current or electrical energy. So these are the 2 sources of electric current. The first thing is what it is? Battery. Dry cells or batteries. What you are finding? 2 volts battery, 12 volts battery, 220 volts battery, like that. So we have so many batteries are there. According to their potential, we have different type of batteries. The batteries can provide the electricity. Now in that phenomena involved, what it is? That chemical energy is converted into the what it is? Electrical energy. If you can consider dynamo in that mechanical energy is converted into the electrical energy. So here our question is what? In circuits, how the current can flow? How we can identify the direction of current flow? That is the question here. So children, in historically or in ancient days, after so many years back, the people can felt that the current is moving from higher potential to the lower potential. Higher potential to the lower potential. That means here the moving of charges. For example, here I am showing that this is the conductor. This is the conductor we are taken. Here positive charges are there. Positive charges we are showing like this. And here I am showing that this is the higher potential and this is the lower potential. Just I am showing. In that conductor, the positive charges are moving from higher potential to the lower potential. Higher potential to the lower potential in a circuit. Clear? That is commonly known as conventional current. What is that? Conventional current. So that means ancient days opinion after came to know that the current is because of flow of electrons. The free electrons which are in the conductors, they only responsible for the flow of electricity. After concluded that, what's that? These electrons can move in opposite direction of conventional current. Opposite direction of conventional current, or these electrons are moves in opposite direction of positive charges. what is a positive charges. That's why simply here the current is moving from lower potential to the higher potential, lower potential to the higher potential. That is the concept of modern electronics. So but we can follow the conventionally. Why? Because generally what we can feel that the water can easily flows from higher layer to the lower layer, but the moving of water, it is not possible to move from the lower heights to the higher heights. Simply the water easily moves from higher heights to the lower heights, but it is not possible to move the water from lower heights to the higher heights. That's why we can follow the conventional current only. Actually here the positive charges can move from higher potential to the lower potential, and electrons are moves from lower potential to the higher potential. But here what you have to say, but in our chapters or in every textbook we can flow, we are saying about the flow of current. That flow of current is, we are showing the only conventional current. You have to follow the conventional current because that is only in textbooks. So to understand clearly, I am drawing very clear here. For example, here this is the one wire, that is the what? One wire, that is what? Conductor. That should be given to, so the AB is the one conductor, that should be given to the opposite terminals of battery. Opposite terminals of battery. Now this is the plus and this is the minus. This is what indicates higher potential and this is what? Lower potential. In our textbooks we will show like this only. That means what? The current is moving from lower potential to the higher potential. So while we are talking about the direction of flow of charges, we have to follow the conventional method. Clear? Remind that. And next thing is, children, we are having some materials which can elose the current. Materials which can elose the current. Children, we know that what's that? The matter should be classified into three types: solids, liquids and gases. So here solid, liquid and gases. So in solids also, some of the solids can elose the current, some do not elose the current. That means solids also having some nature of conductors and some should be having some nature of insulator. What is that? Insulator. Yes, some elose the charges, that should be called conductor. Some do not elose the current, those should be called insulators. So already we have one chapter is there for that, semiconductors and conductors, we will discuss later there. So simply here solids elose the current and liquids also elose the current. Liquids can elose the current. The liquids which can elose the current, those should be called electrolytes. What they call? Electrolytes. Electrolyte. That means, I think in previous classes you learned about the electrolysis. What's that? When the current is passes through the any liquid, the liquid molecule should be going to be splits into the ions like cations and anions. When cations and anions are found, both ions should be moves in different opposite directions. When both are moving in opposite directions, they can easily elose the current. So that means here electrolyte means the solution or the liquid which can elose the current through them or charges through them. That is what we call electrolyte. In a solution or in a liquid, when the molecules are splits into the ions and these ions are moving in opposite directions, when they are moving in opposite directions, there is possibility for the moving of current through the liquid. So that's about the liquids. And next thing is gases. So again same thing, what in liquids also only some of are elose the current, some do not elose the current. Later we discuss that is gas molecules. Gas at ordinary conditions, it is not possible, gases are not possible to elose the current. Clear? Why? Because at ordinary temperature and pressure it is not possible. but at certain pressure and temperatures only the gases can erase the electricity. So that phenomena what we call generally ionization process. So when ionization process takes place, gases also erase the electricity. So simply what you have to say, the electricity can pass through the solids, liquids and gases also. And but one assumption is there, what is that? All solids are not erase the, only some of the solids erase the current and some of the liquids erase the current and some of the gases are erase the current. Some conditions apply. And next thing here, Ohm's law. Oh, this is the well-known thing for you, I think so. Maybe I think so in your 10th class you learned about the Ohm's law. What is Ohm's law? I think you can easily understand that one. Again I am going to try to explain that. Very easy thing. What's that? This is the one conductor. This is what? One conductor. I am giving the name some P and Q. So here we are supplying some potential. We are supplying some potential V. Clear? We are taking one conductor, across the ends of the conductor we are giving some potential. So potential difference is created. Simply here it is given to plus positive charge, higher potential, and it is given to negative. Some potential difference is created. When potential difference is created, then the current will be moved. So that's why here the amount of current that can be passes through a conductor, the amount of current that can be passes through a conductor is directly proportional to the amount of potential that should be applied across the ends of a conductor. That phenomena, that is what we call Ohm's law. Simply to understand the Ohm's law, we have one condition also there. What's that? If there is no change of any physical conditions of conductor, if there is no change of any physical condition of a conductor, simply there is no change in its temperature of a conductor. That means at constant temperature you have to say. If there is no physical changes in a conductor, then the amount of current passes through a conductor is directly proportional to the amount of potential what it is given to the conductor. That is what we call Ohm's law. So here now simply at constant temperature we are writing V is proportional to I. At constant temperature we are writing V is proportional to I. What is V? Potential difference what we applied. And what is I? Amount of current passes through the conductor. V is proportional to I. That is what we call Ohm's law. And now here to equate them we are using one constant, that is I into R. Here what R is what is called proportionality constant. Proportionality constant. So here the value of R, here the R value depends on some factors. The first thing is size of the conductor. What is the first one? Size of the conductor. Clear? And next thing is nature of material. And third one is temperature. V is proportional to I and V is equals to IR. R is what we call proportionality constant and R should be taken as some proportionality constant. The value of R depend upon the three factors, mainly size of the conductor and nature of material. With what type of material conductor is prepared or made, that should be second factor. And third one is temperature of the material or conductor, surrounding temperature of the conductor. So on these three factors we have to say R value should be depends. Then V is equals to, we are writing IR. This is the Ohm's law. And children, already we have definitions in 10th class also there. ohmic conductors, non-ohmic conductors, or ohmic devices or non-ohmic devices. So here the conductors which can obviously the conductors, so what did I say? I am saying now ohmic and non-ohmic devices, ohmic conductors and non-ohmic conductors, ohmic and non-ohmic conductors. So ohmic conductors means the devices which can obey the Ohm's law, they are called ohmic devices or ohmic conductors, and the devices which do not obey the Ohm's law, those are called non-ohmic devices. What we call non-ohmic devices, simply which can obey the Ohm's law, they are ohmic devices or ohmic conductors, and which material do not obey the Ohm's law, those are called non-ohmic devices. And next thing children, here for ohmic devices, if you can plot a graph between V and I, if you can plot a graph between V and I, that gives a straight line, that gives a straight line. So the straight line originating from the origin, it starts from origin. That means here straight line is always represents the proportionality. So there is some proportionality between V and I, V and I. So if we can draw like this, we have to take some I versus V, I versus V, then we are showing like this. Clear? And children, next, in case of non-ohmic devices, the nature of the graph is, it is not a straight line, that should be a other than the straight line, other than the straight line. Simply I am showing like this. This is the V now and this is the I. Simply here V and I. So it is not a straight line like a curve, anything, any shape. That represents the non-ohmic device. For example, PN junction diode or diodes or thermistors, for them we will get like that. For ohmic device we will take metals. Clear? Examples for ohmic device we can take metals are the examples for ohmic devices, and junction diode, semiconductor device and thermistors, those can be taken as the examples for non-ohmic devices. And children, here next thing is resistance. What is resistance? So resistance means nothing but, so what I told you, conductor which can allow the current through them, they are called conductors. Even though they can, the conductors also have some resistance. Here what is mean by resistance means, it is the property that can oppose, the flow of charges, that phenomena what we call resistance, So to understand clearly about that, I will give one general example. You are taking a bowl and that should be put it on a burning stove, and you are heating that. So after keeping the bowl on the stove, immediately you can keep your finger into the water. You do not feel any heat. After 5 minutes, you can give again finger, it touches the water, you can feel some heat. So water gets heated means what? The heat is passes through the water. That's why the water is conductor of heat. But initially the water is not gets heated quickly. Immediately after keeping the bowl on the burning stove, it is not immediately gets heated. Water is not immediately gets heated. It will take some time. So that means during that time the water can oppose the heat. During that time the water can oppose the heat. Clear children? Like that, you are taking a long bar, iron bar or any material, that should be keeping a fire or flame. Up to some time you are not feeling any heat. After 2-3 minutes you can feel that heat, because initially the rod can oppose the allowing of heat through the body. that is the opposition. So like that, even the conductor can elevate the charges, but initially they also, the particles of the conductor initially they can oppose the flow of charge. That is what we call resistance. What it is called? Resistance. Resistance is nothing but the opposition shown by the body to the flow of charges. That phenomenon what we call resistance. So for perfect definition, again we are going for Ohm's law. V is equals to IR. What's that? V is equals to IR. From that what we write? R is equals to V by I. What's that? R is equals to V by I. R is equals to V by I. Here what is R? Resistance. What is V? Potential difference what we apply to the conductor. And what is I? What is I? Amount of current passes through the conductor. Simply what you have to say here now, resistance means the ratio of potential difference applied to the conductor to the amount of current passes through the conductor. The ratio of potential difference what we apply to the conductor to the amount of current that is passes through the conductor, that should be called potential difference. Sorry, resistance. V by I, the ratio of potential difference to the current is what we call resistance. And children, in circuits they will show like this. The symbol means that is the resistor. What's that? Resistor. And in some other times they will show in diagrams like this. This is now variable resistor. Variable resistor. Resistor and variable resistor. So here this is the resistor and this is the variable resistor. Resistor means what? The device which can do not allow the current, that should be called a resistor. In an electric bulb, filament is the resistor. Clear? And which can do not allow the current, which can oppose the current, that should be called resistor here. And this is the variable resistor. So we have to identify that. So children, now here we have another important definition is there. Define ohm. Define ohm. What is mean by ohm? So here this is a ohm. Definition of ohm important for 2 marks, children. Here what is V? What is V? Potential difference. What is I? Current. What is the unit of potential? Volt. And what is the definition of, unit of current? 1 ampere. So here R means what? Here resistance, its unit is ohm. What is that? Ohm. And the ohm symbol is like this. This is the ohm symbol. So resistance should be like 30 ohms and 20 ohms, 5 ohms, 2 ohms, 1 ohm. This is the circuit symbol of resistance. So now here definition of ohm. What is the definition of ohm? Children, 1 ohm is equals to 1 volt for 1 ampere. 1 ohm is equals to 1 volt for 1 ampere. That means if 1 volt potential difference is applied and 1 ampere current is passes through the conductor, when 1 volt potential difference is applied, then the amount of current is passed, how much is 1 ampere. Now the resistance of that conductor is said to be 1 ohm. Got my point, children? 1 volt is applied, 1 volt potential is difference is applied, then how much current is passing? 1 ampere. On that time the resistance of the conductor is said to be 1 ohm. If 1 volt is applied and 1 ampere current is passes through the conductor, if 1 volt potential difference is applied and 1 ampere current is passes through the conductor, then the potential difference, then the potential difference is 1 volt, current is 1 ampere. If 1 volt potential difference is applied, then 1 ampere current is passes. On that time, the resistance is what we call 1 ohm, children. If 1 volt is applied potential difference and 1 ampere current is passed through the conductor, then the resistance of conductor is to be 1 ohm. So this is the definition of 1 ohm, children. Next thing here, children, you want to know about the one more definition, conductance. So conductance, here that should be shown some symbol with G. Conductance, what is mean by conductance? What I told you, resistance, it is a property that can opposes the flow of charges or flow of current. That is what we call resistance. Opposite to that one, so here conductance is nothing but 1 by R. Conductance is nothing but 1 by R. Conductance means it is a reciprocal of resistance. What's that? Reciprocal of resistance. The reciprocal of resistance is called conductance, and here we will identify that conductance is equal to 1 by R. And now here, children, what is V is equals to IR, R is equals to what? V by I. Then what, right? Conductance is equals to 1 by R. R means what? V by I, or I by V. Clear? And children, in case of resistance, what is the unit? Ohm. Now the unit of conductance is mho. What is that? Mho. Reverse. Ohm is the unit for resistance, mho is the unit for conductance. And simply, what is the symbol of ohm? This is this one. Now here the mho should be written as ohm inverse. Ohm inverse. And it is also called as Siemens, S-I-E-M-E-N-S, Siemens, S, like that. So this is, children, about the conductance and resistance. Children, this is about the all these things, all the definitions. I hope you understand. If you can understand this one, like and comment the video and share the video. And to follow you further my videos, please subscribe my channel and press the bell icon for the latest notifications. So encourage me and support me by subscribing my channel. Thank you once again. We will meet in the next video with some other interesting topic. Bye. Take care.